Next, we will introduce the idea of a derivative. Let's consider a function f of x at some point a. We say the derivative of a function f of x at a point x equals a is the slope of the tangent line to the graph of the function at the point a. Analytically, we can express the derivative of a function f of x at a point a as the limit of the difference quotient between points a and b. We can express b in terms of a and h and introduce an alternative limit definition of the derivative of a function at a point. In summary, we define the derivative of a function at a point x equals a to be the value of one of the following limits. If we look at the derivative of a function at multiple points, then we will be able to see that derivatives create a mapping or follow a rule that we would refer to as the derivative function of f of x, or simply the derivative of f of x. The derivative function of f of x produces the slopes of the tangent lines to the graph of the function at any point. The concept of a derivative was independently discovered by two mathematicians at the same time. As a result, Newton and Leibniz developed each their own notations, and since both notations proved themselves useful, we use both of them interchangeably to these days. Consecutively, the derivatives of a function at a point can also be labeled in two different ways. Once you understand the notation, you can appreciate certain mathematical humor like this too, and my favorite one. In summary, we defined the derivative of a function as the limit of the difference quotient as the difference in the input approaches to zero. Using nothing but the definition, we can derive the derivatives of the basic functions that are summarized in the table. So where does the derivative of a function exist? If a function is not defined at a point, then there is no such thing as a derivative of the function at that point. So in this particular example, there is no derivative at x equals 3. Does it mean that derivative exists at every point where the function defined? No. It is possible that the function exists, but there is no clearly defined tangent line at that point, as in this example. There is no tangent at -2. Therefore, the derivative doesn't exist. Does the derivative exist at every point where there is a tangent line? Also no. The tangent line may exist, as in this example, at x equals 0, but remember that the vertical lines do not have slopes. Therefore, if the tangent line is a vertical line, then we say that the derivative doesn't exist, as shown in the example. Again, the derivative only exists when there is a slope of the tangent line. We discussed the definition and notation of a derivative.